Hello, everyone. This is Brad Burwald. Thank you very much for joining us today. I am here with Mike Postel of Connexa. And of course, this webinar is sponsored by Morningstar. The two of us are pleased to present solar-powered security now more than ever, because the world's not getting any safer. And we will be talking about solar-powered security systems in off-grid and remote locations. So just a few reminders before we go ahead and get started. First of all, this webinar is being recorded. So for those of you that aren't able to join us live today, it will be available for viewing offline later on, and also will be available on Morningstar's YouTube channel. So you can watch it at a later point in time, or feel free to share it with others that may be interested. Also, in the handout section of the GoToWebinar interface, you will find a PDF file of the slide presentation so that you can review the slide deck at a later point in time, or also share that file as well. Okay, and again, my name is Brad Burwald. I am Senior Product Manager with Morningstar Corporation. I head up our product team, and I am again here with Mike Postel, President of Conexa. So we will get started, and I'm going to give just a little bit of an overview on Morningstar and our products, and then I'll be handing it over to Mike to take you on a detailed presentation through the many off-grid security products that his company offers, and away we go. Okay, thanks very much. Next slide. Yes, so again, there is Mike Postel, President of Conexa, and myself, Senior Product Manager at Morningstar Corporation. Next slide. A little bit about Morningstar. We like to think of ourselves as the charging experts when it comes to off-grid solar battery charging. We have been around since 1993 in this industry quite some time, and have over 4 million products deployed in the field. So we've seen many generations of our product line evolve, improve, and also stand the test of time around the world. Our products have been sold in over 100 countries, and our primary focus for our product line and our expertise is mission-critical applications. Some of the many verticals in which we participate are as follows: residential and rural electrification. So these would be in developing regions where there is no access to the electric grid, and we provide a lot of these rural electrification programs, including participation in extremely large projects from time to time, one of which was notable that just wrapped up last year, and that was the deployment of 200,000 home-based DC energy systems utilizing Morningstar Power Electronics. Also 3,000 community centers, including AC power and more extensive equipment, some in the healthcare field, powered off-grid. And this enabled support for over 1 million people to receive electricity access, whereas they were otherwise unable to. We also support commercial applications, a particular focus in industrial applications, including telecommunications, oil and gas power, as well as security, the focus of today's presentation. Also, mobile, marine, and agricultural applications are also within our area of expertise. And we're very proud to have the published lowest hardware failure rate in the industry, because we've got the volume and we have the reliability and the quality to definitely show that that is true. Next slide, Mike. So we'll be really focusing on Morningstar's professional series line today. That would be the line of our products that are focused on these mission critical applications. This includes such products as our TriStar family of controllers, the ProStar family, the one that really started everything with Morningstar, going back 3 generations, the SunSaver product line, including also PWM and MPPT products, and also a variety of solar application-specific products, such as the Sunkeeper, Sunlight, SunGuard, and last but not least, our SureSign inverter, also designed exclusively for off-grid applications. Next slide. Morningstar's product line is made up of a variety of PWM charge controllers as well as MPPT controllers. Both have a strong place in the market today, depending on your needs, the solar module configuration, and the modules you choose in terms of voltage specifications. All of these products can provide a variety of options and different power levels and efficiencies, depending on your needs. We also have a group of inverter products, including our SureSign and our upcoming multi-wave inverter charger. And all of our products are compatible with a variety of accessories, namely the EMC1 Ethernet meter bus converter, which we'll be talking about specifically in this presentation, because it provides enhanced data connectivity options for Morningstar products. Okay, next slide, please. To go into just a little bit more detail about the EMC, because it is a very prominent product, and the needs of remote monitoring and data are really of critical importance in 2020 and beyond. So we see a lot of these products being supported in the industry. And what this does is generally the variety of products that are in our professional series that were on the previous slide have data connectivity options. And with the EMC, they're also imbued with simple network management protocol, as well as Modbus over IP communications. And these are two very important protocols. SNMP being used extensively throughout the IT infrastructure, also used by oil and gas. And anytime you have specific network connectivity, including security cameras, which are often IP-based, you can use SNMP monitoring. Modbus is always the de facto standard for communications in industrial systems, and that protocol is also available on the majority of our data-enabled products. So I will leave further discussion on the EMC to Mike, who will also be covering specific IoT solutions that his company offers, and that's going to be a pretty recurring theme within this presentation. So with that introduction to our products and the EMC, I will now hand over the presentation to Mike, and he can take it away on the security applications that we're here to discuss today. Okay, go ahead, Mike. Thank you very much for joining us today.
Thank you for that intro, Brad. And once again, I'm Mike Postel, president and founder of Conexa. A little bit about what we do. We are integrators and suppliers of remote solar power products and systems, also UPS power backup. We're headquartered in Comfort, Texas, which is a small town just outside of San Antonio, Texas. We've been supplying remote power products since 2006. And a little bit about my background. Back in around 2006, I had a small IT company where we were doing a lot of networking. We got invited to do camera hardware in remote areas. So we had a need to power those devices. So that's when I personally got into powering security devices. And it was back whenever there was a brand called IQI, and the IP cameras were just coming onto the scene. And of course, being an IT company was a natural fit to move into that IP camera world. You know, we had our Alarm B license back then, and had been doing power systems for cameras ever since. So I have a lot of personal experience in this particular area from the beginning. As far as what our company does, solar and DC AC UPS are our primary products. We specialize in remote areas, but also do work in areas that may utilize our products that are not necessarily remote, closer to some facilities and whatnot. And we have a full line of not only systems, but components. So we have everything from solar modules, cabling, structures. We have the full line of Morningstar controllers, solar batteries, enclosures of various sorts, which we'll talk about, and as well as PoE electronics for the security industry. We have an in-house panel shop, which we manufacture all of our backplate assemblies internally. It is a UL and an ETL certified panel shop. All of our structures we make in-house as well. We do in-house steel and aluminum fabrication. In 2019, we implemented a Comax Zeta, which is a best-in-class wire robot, which processes wire barrels up to 36 behind it. And the room is about a 20 by 40. Would love to give anybody in the area or passing through a tour one day, but it essentially cuts, strips, terminates, and labels the wiring that go into our systems. And then we have a large stocking warehouse where all of these components await assembly or shipment. So one of the reasons for the presentation today is we believe security is a top growing industry. Being that you're using a lot of electronics many times in remote areas, we feel like solar is a natural fit. And a lot of the electronics being DC especially. Solar has become more cost effective, and I believe it's easier to deploy than ever. The physical size has come down also. And I think solar provides a natural fit into security in the sense that it is independent. And it will be there just in case there's another power source that is having an issue. This is a very basic overview of a system. On a normal system, you're going to have your solar panels, which we would call a solar array when they're put together. They're going to be assembled onto a structure. These structures come in various types, but let's call them solar mounting brackets, which in this particular case, this is a pole mount system, and it would all be assembled onto a pole. The electronics enclosure holds the batteries and the electronics, but in some cases, these could also be split up. And then inside, we have the Morningstar charge controller, which is going to regulate the charge from the solar array to the battery bank. All of our systems come with breaker or fuse protection. And then the PoE switch or injector, which we'll cover in a brief moment, is inside of this enclosure. But I wanted to also talk about the SureSign inverter for AC systems is an add-on that you can put into any of our systems. A couple solar friendly areas of installation for surveillance. I just want to go through a list. Parking lots are great. Entry gates, typically away from power. Yard monitoring near facilities. Ports, roadways on portable lines, job sites, either for surveillance or for capturing images. Bus stops. This would be in municipal applications, farms and ranches. Mining applications have very large areas and not very readily available power. Marine and landfills. A couple of the camera types that we support are going to be the bullet style, domes, and then also the PTZ. So other areas of security I wanted to talk about is access control. And solar can be used and is really good for gates and openers. We power a lot of different motors in a lot of different industries. So our current capabilities are able to power with solar up to 480 volt 3-phase motors. And of course, everything down to DC motors. Solar is also great for the card readers, the sensors that are going to be on the gate and nearby. Cameras, of course, alarms, and lighting, as well as the communication, which in the solar application is usually wireless. Intrusion detection is another area that has security electronics. Solar is great for the ground radar and radar video surveillance. Thermal cams are becoming more and more popular as their cost is coming down. Perimeter detection, which can be located on fences or elsewhere. Ground detection for very sensitive sensors, and other various wireless sensors for intrusion detection. Lighting is something that is important for the security industry, and I know that a lot of the cameras have definitely increased in their capability of seeing at night, but sometimes a little help is needed. And so we have solar options for area lights, which can be mounted on a pole or the side of the building, street lights, and spotlights. These lights that we offer actually are very universal on the mounting. You can typically get them where you need, but in the camera world, IR illuminators are something that we see as common to light up a particular area for your cameras to be able to see a little bit better. Warning strobes and sirens. This would be good if you did want to trigger a warning or an alert remotely. You could do that with logic or if they were being remotely viewed. So these are all within the portfolio. And I wanted to toss a slide in about industrial cameras, which may not necessarily be used for security, but they do fall within the umbrella of what we're talking about here. So you have a lot of imaging that's possible with these thermal cameras. So thermal tank imaging, thermal equipment inspections, as well as gas leak detection. So keep that in mind when you're thinking about thermal cameras. Some of the common challenges: power availability. So line power not available is probably the #1 reason to put in a solar power system. But sometimes line power is available. You just might not necessarily have permission to access a particular meter or the available power next door. Cost of trenching is generally pretty expensive depending on where it's at. Let's say you're in the middle of a parking lot, it would be pretty costly to trench over. So throwing a solar power system up to power those electronics would be a more cost-effective option in a lot of cases. Line power reliability, being in the nature of what we're doing here in security, having something that is independent of line power can be helpful on the critical applications. Temporary projects that need to be moved, if they're not going to be there for a long time, sometimes it makes more sense cost-wise to use solar so that you can move it around job to job. It also allows you to put let's say in a camera's case, or even a wireless access point, you can put the placement in the perfect location. So solar solves some of these problems by being standalone, like we talked about. It's very reliable. The technology is pretty mature, and it's increasingly easy to install, being that the panels themselves are getting smaller, seems like every year. Next, I want to talk about power over Ethernet, which is a really tricky thing for the security industry. And I'm going to go through a little bit of an explanation of the standards, how it works, and some of the common challenges. This is the area that we see as being the most challenging for hooking up security applications. And basically we have a lot on the call, so I'm just going to go across the basics at first, but power over Ethernet is basically passing electric power in addition to data over twisted pair Ethernet cable. So we're going to do power and communication on the same cable. There are two types. There are active and passive, and the active is going to be based on the current 802.3 standards. There is the important thing to understand about active PoE is there's a handshake. So if the power source and the load do not comply with the standard, no power will be put onto those pairs. This being a standard is already dictated and there's no way to change the voltage. So your 48 volt is the nominal voltage on these systems. The power is regulated and also comes with various protections inside of the injector or the PoE switch. It's very common with VoIP phones. A lot of wireless is going to this. Of course, it seems most cameras are coming PoE these days, as well as different areas of office equipment. But the other type is passive, and passive is a little bit less sophisticated. Essentially, what we're doing is adding power to the unused communication pairs inside of an Ethernet cable. And this is unregulated and has the potential to cause more complexities, in the sense that whatever power you put onto those wires will actually go through to the load. So we really have to be diligent to make sure that we're putting the right power onto those wires. And there's no control or negotiation at all. Typically, we see on the passive side 24 volt loads, but being that it's unregulated, you could have passive PoE anything, 12 volts on up. So it's not protected. Keep that in mind. Just want to be a little extra safe. And on the larger systems, we see passive is a little bit more common because the active standards are still catching up, which we're going to go to here on this next slide. Beginning a couple years ago, came out with type 1 802.3 AF, which are 15 watts per port. And this still will handle a lot of cameras, a lot of bullet cameras and lower power cameras are 15 watts or less. But PoE Plus is now here, which is becoming more popular, and up to 30 watts per port. That's going to capture, I would say, the rest of the mainstream cameras. There are increasing power needs by the newer cameras, especially when you get into PTZ, and some cameras might actually have heaters. And so we see those power needs growing. So we have PoE++, 802.3 BT. There's also a BU standard, but we're looking at 60 watts on these guys, and then the Type 4 being 90 to 100 watts. So it is growing, and we definitely anticipate that to continue that trend. I want to touch on the difference between an injector and a switch. So a PoE switch will take the power source, which in this case would need to be 48 volt DC if it does not have a converter inside, and it'll directly power your devices. So this is definitely the most, I would say, or the easiest way to hook up a PoE device is to have a PoE switch. And this would be if the load devices are following the 802.3 standards. You just plug it in and you're ready to go. If we wanted to go the injector route, then typically the switch used is not a PoE switch, or the load device is a non-standard or not following the current 802.3 standards device. And so what we do is we take our communication via the Ethernet cable from the switch, and we go into an injector where power is applied to the extra wires inside of the Ethernet cable, and then it sends it back out to the load. These injectors can actually be active or passive. So typically on a PoE switch, at least from what I have experience with, they are all following the active standards. But on the PoE injectors, we could have a passive injector or an active injector. So this is probably the most difficult area of hooking up security power systems. You have in the security world, as we talked about earlier, a lot of different devices possible. You have these sirens and these warning lights, as well as typically, if you're using solar, you probably are using wireless, not always, but most of the time. And then you have PoE active standard cameras. And so it can be a little bit tricky to get all of those up and going on the same system, because let's just say, as an example, your main siren might be a 12 volt DC siren, and then you might have potentially, as an example, a 24 volt passive radio for the wireless, and then you'll have an active PoE standard security camera. So to get all of those to work on the same system can be a little bit challenging, and we see the future coming to where everything will probably be corresponding to the 48 volt standard. But as of right now, there's still a lot of equipment out there that is passive PoE, 24 volt, as well as in general, you typically have on these systems some sort of 12 volt load here and there. And so it's really important to plan out the different systems and make sure that you have the power available for each one of your loads. The wireless industry, as I said, is definitely one that you're going to see a lot of 24 volt passive in. So just keep a lookout for that. On these systems that we supply, we have both solar power systems and then non-solar AC and UPS. Showed you a picture of that here, but we try to make it easy. So what we have really strived to do is have the easiest installation with the lowest amount of effort out in the field, because you have other challenges on the install, and we want to make it easy and universal as possible. So there is a way to have some of the DC to DC conversions happening within inside the switch, and we definitely do that where able. So a very common system is us providing a PoE switch with the ability to plug most if not all of your PoE devices into the same place, just making it easy. Separately is split out some terminals so that you can wire your direct DC loads. And this would be really common on a cellular modem application. A lot of the cellular modems that we work with are going to max out at 24 volt DC. So very common, we're going to have active PoE standard cameras and a 24 volt, 12 or 24 volt cellular modem. We've come across a couple nuanced challenges here in the PoE world on the higher wattage. There are a couple brands and a couple models, actually a couple models within some of these major brands that do a little bit different handshake than might be standard. And so we've had situations where some of these cameras, very popular models, will plug into they might be both complying with the standard, but you'll plug into a normal PoE switch and the device will not power up. So keep that in mind. There are some of those cases happening on the 60+ watt cameras. And hopefully some of those will get cleared up, but whenever that happens, there needs to be a little bit of configuration on the inside of the PoE switch to accommodate that, but definitely doable. A little bit of a summary on PoE, just some tips. So in simple applications, combine the switch or combine the PoE and the switch for the most cost-effective solution, and also for the ease of the field labor. Try, if possible, to design the system in such a way that it is all going to be coming off of the PoE switch, if possible, for simplicity. And of course, in more advanced networking and for infrastructure applications, consider those mid-span injectors. There's a lot of different types out there nowadays. They're actually not too incredibly difficult to hook up. You just have to hardwire them in. The major tricky part there is going to be making sure that you are injecting the right voltage. And then account for voltage drop, especially if you're going a long ways. These Ethernet cables are good for a certain distance, and there are things you can do to extend that, but definitely calculate that. If you had for an example, a passive PoE wireless device that was 24 volts, then you're going to have a different cable length maximum than if you're using the 48 volt for an active PoE. And this is a nice feature to look into switches that have remote control capabilities, managed switch or some sort of watchdog features, so that if you did have multiple loads and then you did have something go dark in the field, you could do a power cycle on that and try to recover it remotely. Communication, our normal radios that we're powering these days, of course, the 802.11 standards with Wi-Fi. There's a lot of different radios out there, and we see them really, depending on the brand, on all voltages, anywhere from 12 volts all the way up. Some of them make it a little bit difficult to connect DC at all, in which case you have to go through AC. But on the shorter range, 900 megahertz to 2.4 gigahertz radios, we see as they're, let's say bouncing around a site locally. Microwave for a backhaul, and a backhaul being that you're going to take a local site with multiple cameras or devices, centralize that into one backhaul spot, and then send it across the link back to another location, which could be miles away. We see cellular as the cellular networks becoming stronger, being the go-to choice for backhaul. Cellular modems are pretty cost effective nowadays and very reliable, and the data transmission rates are pretty quick. So they're becoming very popular. On satellite, that is an option that you can have if you are looking to transmit images. I would say there's a latency issue to worry about on satellite, but don't roll it out if it's an area that you cannot get any cellular service at, you can actually send back images and video to some degree across that satellite, but definitely a more costly route to go, and your data transmission rates are going to be slower. Antenna types, point-to-point and omnidirectional. This is where you can set up what we would call maybe like a base station and nodes. So let's say you had a site where you would have a centralized, we'll call it a base station. It's going to have the core of your electronics for the entire site. It's going to have your backhaul. It could have your NVR or whatnot for recording. And then you can place smaller solar power systems out on the nodes and then do a point-to-point radio back to the base station. So that's pretty common that we see. Try to centralize the bulk of what you're doing for the entire site in that base station and keep the nodes as small as possible. Some of the challenges we see on installation, proper sizing is key. I'll go through a couple of different bullet points on that. Whenever you're doing system sizing, you want to make sure that you are sizing and doing calculations based on the average sunlight in the very specific area where it will be installed. On the right, you can see this chart that we use, the yellow being somewhere in the ballpark of a 1 to 2 estimated sunlight hour region. And then of course your darker reds are going to get up to just off memory, somewhere around 5.5 to 6. So it's really important to size properly during the summer. If it was undersized, you might not know it in the summertime, but in the wintertime, especially when the sun starts, the whole track across the sky is going to be a lot lower. Factor in the angle of the solar array and just make sure that you've factored in the estimated sunlight hours based on what we use NASA weather data, but good data averaged out. Battery autonomy is very important for the wintertime. So we are, as a company, recommending a minimum of 5 days of autonomy for all systems. And if it's more critical, we would actually step that up to a 7. On a lighting project, we might go below 5, but right now, our company standard is 5. And what that's going to do is allow for the wintertime sun to do its thing, and you do get a little bit of charging, but it's greatly diminished in the wintertime whenever you have cloud cover. So the nice part about the wintertime is that whenever the clouds do pass and the sun comes out, it's cold, and the solar panels love that. So you're going to get a lot of good power out of that. Sizing the charge controller is also critical. Make sure that you are choosing PWM versus MPPT, and you're making sure that there's good reason behind that. You don't want to, for instance, oversize the solar array on a PWM. Make sure that everything's calculated properly on the voltage, as well as your wire runs and whatnot. The load duty cycles is something that we are working with our customers constantly with to try to get the system down to the minimum size required. And so when you're looking at the spec sheets on your equipment, especially as an example in the wireless world, your wireless radios, a lot of those manufacturers are going to publish a worst case transmit figure for the power, and that can be high. Let's say you had an application where you were recording on a camera locally to maybe an SD card, and you were only transmitting occasionally, or maybe the only data going across the wireless link is if you're remote viewing it. So your transmit is actually going to be significantly lower. So don't necessarily think that you have to have a large system per se. It's nice to factor in the load duty cycles and come up with a more real world number. PTZ cameras, as well as this next one, heaters, these can draw larger amperages, and it's important to, in order to size the system properly, you could do it one of two ways. You could actually size it for the worst case scenario, or you could, if you wanted a more realistic real world number, you could look at, what is the PTZ camera actually drawing after it's, let's just say, stabilized in a certain position. Maybe you don't move the position of it, but every once in a while, or only while you are, let's say, live viewing, that would be a lot less power per day than if you use the spec sheet maximum. So just keep that in mind. To be on the safe side, always use the maximum, but the system size will be larger if you do that. Seasonal loads are important to factor in. If you have a load that is, or a device or whatnot that you're only using during the summer, that would be a different calculation on system size than if you wanted to run it all year round. And you definitely want to factor in on the camera, just to back up one, the camera heaters, any type of electric heater and solar definitely needs to be planned. The heaters are going to be running during the season that is actually the least amount of sun, so it needs to be thought through so that your system stays up year round. Day and night using the charge controllers is a really nice thing. If you had a light that you wanted to turn on at night, which is recommended to turn off during the day so that you keep your system size as small as possible, you can actually use the Morningstar charge controllers or specific models to do the day-night control. And essentially, it's going to be looking at the solar panel to determine if it's day or night, and then you can take an action after that, turning the load on or off. Temp ratings of the electronics that you guys are using is very important to factor in, because the cabinets need to be able to either actively heat or cool, or the electronics, or even insulated. We have insulated cabinets as well, but there can be some pretty hot locations if you had a steel or aluminum enclosure. As an example, where we're located in the middle of the Texas sun during the summertime, it can be pretty hot inside, and you just want to make sure that the equipment that you're using is industrial rated with high temperature range. The load voltage tolerances is something to keep your eye on. This is something that we've seen come up over the years. If you had a load that was, as an example, let's say a 24 volt load, whenever you go to charging a 24 volt battery bank, the voltage is going to go higher than 24 volts. And if there's a situation where your load device cannot take that range, then what needs to be added is a DC to DC converter. So even though you have a 24 volt nominal system, you want to make sure that you are, in this particular example, giving 24.0 volts to the load. So the converter would just be taking it, let's just call it around 30 volts down to the 24.0. I would say most electronics do have the tolerance required. So when these manufacturers have a 24 volt rating, it seems most equipment is able to take the voltage for charging a 24 volt battery bank, but you definitely just want to keep your eye on that. Mounting can be tricky, especially in these remote areas. One of the things that is nice generally is to have the cameras at least, let's call it 15 feet in the air. And there's also a lot of benefits to having your wireless antennas up in the air. So what we try to do is provide a variety of mounting styles to accommodate all of these situations. And there's a lot of options out there. On the mast, you can have something simple, which is something, let's call it a square or a round tube that would fold or be installed in the field. And you can do all the way up to a telescoping mast, electric being the most expensive, and crank up. Also nice if you don't move it a lot, crank up's a nice option. So there's different options to do. After a certain height, you have to look at guide wires. So it gets to be a little bit tricky to determine how do we get the maximum height and the least amount of effort on the install. And sometimes it's necessary to do guide wires, and that's what you do. But you can see some examples here of structures that we build. These structures have the ability to add poles, towers, masts of various sorts to them. Some outdoor considerations are that we have seen in the security industry. Wind, whenever you have an install that is outdoor, wind can move things, and one of those is the cable can actually move regularly in the wind. And if you don't have an industrial connector there, then you could have a failure of your connector. And so it's very important to pick the cable and the connector for the job. All of your cables definitely need, and enclosures and mounts definitely need to be UV protected and UV rated, as well as moisture. So these can actually cause you problems in the long term. Sometimes you have an install that you don't notice problems for a little while, but then over time you actually see these problems start to surface. And the goal is to prevent failure for sure, but also to prevent a field crew deployment. So we really, which are very costly, we really want to make sure that the installs are long lasting. Some of the industrial connectors that we use, RJ45 and M12. M12 is very secure. RJ45 is what you're used to, but definitely have industrial versions of that. And then the enclosures, NEMA 1 being indoors, 3R is vented, it's basically rainproof, and then 4 and 4X are going to be sealed. So for reliability, line power, so we do solar as UPS and then also just UPS. So you bring line power in and you can power the loads directly. It's nice to have solar on there. If you did have a long-term line power failure, then your system would be up and going. Some add-ons, a wind turbine and auto start generator. The auto start generator is really nice to use with the Morningstar RD1. You have some controls and logic there. But a wind turbine is really nice for 24/7 power on your system. So speed up a little bit for timing. On storage, the micro SD and SD cards we see becoming increasingly popular, so you can store locally. NVRs, definitely, if you're going to store a lot of video, these can be solar powered. Considerations for NVRs would definitely be something that would fall within traditional servers. You want to make sure that your cabinets are temperature controlled if necessary, and vented where necessary. Edge processing is a newcomer, I would say, at least the term used here, where as analytics are becoming more popular, and I know a lot of this happens inside of the cameras, but as analytics become more popular, we are seeing the need for edge processing that would analyze data and make decisions that is on the physical site, and it does not depend on the data link to the cloud. And so as the future is coming with machine learning and AI, we're going to see a lot more of edge processing. So last, I want to talk about data. Two devices, our Conexa NOE and then the Morningstar EMC1. I want to briefly talk about why add data. You can troubleshoot your site remotely. A lot of this is about not deploying field crews. So if you did have an issue on a site, let's just say you had primary communication failure and you had one of our NOEs on the site, you could cycle the radio's load. So we want to optimize the system by analyzing our data. Hopefully we can prevent failures from happening and then perform actions such as resetting the controller remotely. Brad mentioned earlier a couple protocols that we use, Modbus and SNMP. And then on the cloud side, having a front end, which we have on the Connexa NOE, as well as integrating with the popular the platforms out there on the back end, which is AWS, Azure, and Google Cloud Platform, and then making that data available via a REST API. So our Connexa NOE, the main reason to use it is that it's plug and play with the Morningstar line. We actually came out with it just for Morningstar products. And we act as a single vendor for an all-in-one hardware, connectivity, data storage, and alerts. It is pretty easy to hook up. When you actually plug a charge controller into it, it will actually query the cloud and pull the latest firmware down. It's very easy to install. We have taken care of all of the Modbus work for you. We have full documentation packages online, as well as 2G, 3G, and 4G LTE options. Here are some of the data fields in the Modbus tables that Morningstar has built into a lot of their charge controllers. Many people don't know how many data points are available, but there's actually a lot. And some of the data points would include, of course, solar voltage, charging amps, your load voltage and amperage. We can tell the battery voltage. We can tell if low volt disconnect is engaged, as well as you can take actions. So some of those actions could be to remotely reset the charge controller. You can even factory restore it, turn the loads on and off, and various things like that. One quick note on this, being that and with NOE and everything going to data, it's going to allow, especially with the cloud interaction, it's going to allow a lot of really neat features coming in the future. One of the things on our development is to integrate changing charging algorithms and values remotely. So you can analyze that data and then possibly change some of the internal charging characteristics of the controller. And this is going to be more and more important as lithium batteries come out, because as they become more popular, there's a lot of custom settings required in order to optimize charging batteries. Connecting to the National Weather Service API is coming so that you can actually query and look at the forecast and then make a decision whether or not to turn a load off or not. And lastly, remotely controlling breakers. These breakers that are coming out now can be smart and can also have Modbus communication. So looking at a lot of neat features like that coming out in later versions of NOE. And NOE is actually set to launch in January of 2021. The future of security looks like it's going to be more power, more and more power. These devices are doing more tasks. These cameras are becoming smarter, and there's a lot more analytics happening. We anticipate that to increase. So it's going to be something to look out for. These standards should be catching up, I would imagine, pretty soon. Integrated security, there's coming an ecosystem where you, as an example, to tie into the last point, drones, you may have a gate that has a certain sensor that triggers an event that a drone would get deployed, possibly, do a flyby video, and then maybe your PTZ cameras would point at that spot, different things like that. So you have another layer that is going to allow everything to collaborate together for security purposes. But that's the end of my presentation. Once again, I'm Mike Postel with Conexa. Find me and follow me on LinkedIn. I'm very responsive. If you have any questions at all, you can definitely chat with me on LinkedIn, and I'll respond to you and try to help you out. And Brad, you want to come back on? And
Yes, definitely. Thanks, Mike. I appreciate that presentation. And in off-grid and with these remote power systems, Morningstar, and working with in partnership with yourself and others, we get to know so many detailed information about these different industries. And it's really interesting to take such a deep dive just in security, because this is a kind of content, getting a subject matter expert like yourself on here for all of our customers to really learn from is really beneficial. So I mean, even myself looking at this presentation, learning about the different types of towers, extended, powered, hand crank, ballasted solutions. You guys have really invested a lot into the different types of mechanical deployments. So it's really interesting to see all these options. Um, One thing I was going to mention is that the edge processing you mentioned, we had a customer some time ago that actually was putting security cameras in at their industrial process sites for gas processing applications. And it wasn't just to get eyes on the site for security. They were actually using edge processing with the camera to detect distortion in the air from gas leaks, obviously detecting fire. Like they replaced a variety of sensors with just a camera that actually had the ability to look and interpret what it was seeing and trigger an alarm. So it's really fascinating what you can do with a lot of this security. It's not just remote eyes; it's actually analyzing a site. So it's pretty interesting. So yeah, thanks again. With that, what I'll do is I'll go through some questions. I had a few come up here, and both of us can take those depending on the topic. And let's get started with some of those. The first one I wanted to address was you mentioned you use both PWM and MPPT. Obviously, PPTs are a little bit more efficient and have different configuration options. But when do you typically make the choice on using a PWM versus an MPPT for these types of security systems?
Yeah, a couple things immediately come to mind. Definitely system size. We are using, I would say, the majority of our larger systems are going to go to MPPT. I think that it makes a lot more sense. Definitely, when you look at getting into using solar panels out of the grid tie world, which are going to be your 60 cell or your 72 cell panels, the MPPT really makes those possible on lower voltage systems. And you can, definitely, if you took a 60 cell, you could charge a 12-volt battery bank. But even when you get into those size panels, we typically want to go MPPT to gain efficiency, and also just it's something that we've kind of made a habit out of doing. The smaller systems, you also, if you need communication, all of that line is ready to go. So I think that's the future. I think is heading there, but we do also use a lot of PWMs. I would say they're generally on the smaller systems.
Okay, thanks, Mike. And do you find is it pretty typical to use a 24-volt nominal battery system so that you can provide passive 24-volt, or you can up convert to 48? Is that a common configuration, or have you found yourself using ever a 48-volt nominal battery?
So on a smaller system, let's just say picturing some of the pole mounts that I showed, we would go in at a 24-volt nominal, and that's going to allow us to power most of the radios. And then we're going to step that up to the 48-volt active standard within the PoE switch. That's our standard, just to make it easy. So the customer has terminal blocks for the 24-volt load, and then everything else is right into the PoE switch.
Okay, great. Um, Another question was, now you talked a little bit about, and again, a really important point on the mechanical side, if you've got outdoor connections, I saw you had some RJ45s with rubber boots or seals on them. You even used I believe it was the M12 standard, like a different type of data connection. I had a question is, do you use any type of a sealant or a grease to actually seal those ports?
It depends on the entry connections recommendations. So we typically, let's say, commonly you might use a cable gland. So if the standard is to use that, then we definitely do. But yeah, keeping water out is a little bit tricky as far as you want to make sure that these guys have done all of the testing at these various connectors and gland manufacturers. So we definitely want to follow their standards for that specific connector.
Mhm. Okay, great. An additional question I had here was, what are there any, now you talked about a variety of manufacturers of cameras, and obviously when you get into motor control, like the pan tilt zoom of the PTZ cameras, or the heater type, they can draw a lot more power. And Mike, are the heaters, is that to actually prevent condensation within the dome? Do I have that correct?
Yeah, I believe so, Brad. I'm not a camera expert in that sense, but I do know that I do believe that's what it's for.
Okay, just like a little bit of like humidity control or something. Okay. So
I
one
believe
question was, and I think you touched on this, you said that the cameras that are generally more power efficient are the ones they're not a streaming video application. They just store the data locally to an SD card, and they only actually transmit when they're being remotely accessed. Are there any cameras you've encountered in the industry that are optimally designed for really low power applications, like for off grid? Like we had one question, they said, is there anything you have to do to optimize the camera to make it extremely low power?
I don't program a lot of cameras. It's been a long time since I've done that, but I would say that from what I hear, that's more possible on the wireless radio, because you can essentially tell it to go to sleep. Being that these cameras now are essentially little computers, little servers, they have to be on to a certain degree in order to perform their task, whether it's recording or not. So I would have to say that in my experience, I have not seen that as much on the camera side as on the wireless side.
Okay, gotcha. Okay, very good. Just looking over here. Let's see here. One other question. Are all of the on the NOE, are all of the current levels available? In other words, can you see the current from the PV module, the battery charge current, and the load draw current as well? Is that all available on your NOE IoT system?
Yeah, so we have essentially 3 different areas on the NOE on the dashboard. And we do have the ability to push natively into the back of AWS or Google Cloud Platform. But we have a certain amount of data represented, which you might have seen briefly on one of the screens on a dashboard. So you can log in and see the basics. And then there's a place that you can actually query any of that data directly out of the Modbus table on that particular controller. And so you can go in and request any of those data points that Morningstar is storing. Another thing that you can do lastly is there's an actions area. So you can go in and send any of the actions that are available to send using the platform.
Okay, great. Thanks. Mike made a really good point earlier talking about operational voltage windows, for the devices. Like a 48-volt device often wants to see, between 46 and 57 volts, or just as an example, those types of ranges. And, one of the things we always state at Morningstar when supporting a lot of these products is that just because something is DC rated doesn't mean that it's battery voltage rated, because as we know, battery voltages do swing, especially lead acid, especially in where you have varying temperatures. So one other question from one of the attendees was, what you mentioned a little bit about lithium batteries. What is your battery chemistry of choice typically? Like how much have you done in lead acid versus lithium?
Our normal battery of choice that we use the most is going to be AGM. The second would be gel. Lithium is definitely the newcomer on the block, and I think that it's going to be coming on stronger and stronger, especially, I know, Brad, you guys have a program for integrating your charging electronics with lithium batteries. So that's made it a lot more possible, but AGM and gel are our choice at the moment.
Okay, great. Yeah, in anticipation of this, we do have Morningstar's Energy Storage Partner Program, which is what we've done is we've reached out to a lot of these battery manufacturers, specifically those that are working in industrial applications just like this, and we've worked out a lot of those settings ahead of time and put them in configuration files. All of these products that are compatible with data connectivity, like the NOE and others, can also be programmed to use these custom settings. So we do see a lot lithium. Lithium is interesting in that it does have a much tighter window. It has a stiffer voltage range that it really adheres to and doesn't move or travel as much as lead acid. So it can be an interesting choice here. You just have to be a little bit careful about more extreme cold because it's not able to be charged in very cold temperatures. So, but yeah, take a look at the ESP program on our website and you'll find a variety of support there. So, okay. Very good. I will glance to the questions just a little more. I think, let's see, one more second here. Okay, you did, one last question. We'll take this and then we're just about at time. Could you just restate, there was a question, when you have no cellular communication at a site, what would be your go-to solutions where the cellular communications are not available? You don't have network coverage. Would that be the satellite based?
Yeah, in certain cases, that's the only choice. And if you can get around the latency issue, and there's things that you can do if you don't want to stream video. Let's say there's a lot you can do locally now where the camera can make decisions. And so if you're doing that, you're going to be sending a lot less data back. And I think that satellite could be definitely an option for the camera industry.
Hmm. Okay. In some cases, now these obviously you want to put the camera where you want to put it, and the site really, of the visibility is what really takes precedent over anything. So obviously the network, if you don't have that, then you don't have any connectivity at all. Again, in oil and gas applications, we did see a project one time where obviously a particularly large company that was doing a lot of automation within a certain region had enough funds available. They actually put in place a private network of point to point. They basically created their own mesh network where there was no cellular connectivity. That's usually not an option for just anybody, but they had a particular investment in a specific valley, and they put that in. I think it was something deployed by what would now be the company called Cambium. They were point-to-point radios, and that included
Yep.
monitoring as well as some of the the cameras as well. But just wanted to mention
Yeah.
that. Yeah,
Yeah, more
we
of that's
see some satellite. Go ahead.
more of that's coming also with the private LTE that's coming out for the wider areas that Wi-Fi can't be a part of. So that's definitely something we're hearing a lot of buzz about.
Hmm. Yeah, that's right. And then some very low power, low data rate IoT. But in the case of video-based cameras, that's usually those are not sufficient enough. You've got to have something pretty good. But yeah, private LTE, another choice. Yeah, we're seeing a lot of interesting technology come about, especially in rural areas. I know there's a heavy push because of the current environment with COVID and needing to connect these rural communities for education and just possibly entertainment since we're all stuck at home during this time. So there's lots happening in 2020. Okay, well, those are, I think, all our questions. We have some others here. If we didn't get to answer yours, we'll try to add those or get back to you individually after the fact. So really great experience learning about all this, Mike. Thanks for joining us today. And thank you to all of our attendees who participated. And please look for the recording and the slide deck after the fact. You can grab the video here in the next day or so, and the slide deck is available now. And please tune in again for more of our partners presenting on some of their solutions. And again, I'm Brad. This is Mike from Conexa, and have a great afternoon. Thank you.